Welcome to the lecture on well hydraulics. In the previous video, we have discussed regarding constant level test. So in this video, we shall discuss regarding a recuperation test. So what is recuperation test? The constant level pumping test gives accurate value of safe yield of an open well. It is sometimes very difficult to adjust the rate of pumping so as to maintain a constant level of water in the well. In such circumstances, a recuperation test may be adopted, which is described below. So, in the previous test, that is constant level pumping test, we have discussed that initially, with the help of a good capacity pumping set, the water is withdrawn with higher rate. Afterwards, after achieving a certain level, the pumping rate is adjusted in such a way that inflow is equals to outflow, and that outflow will give you discharge with the help of special type of arrangement. We can estimate it, we can measure it. But in case of this constant level pumping test, the difficulty is to maintain a constant level. It is little bit difficult. So, to improvement on this, recuperation test can be carried out, can be performed. In the recuperation test, water is pumped from the well so that sufficient depression head is developed. The depression head is measured and the pumping is then stopped. The water level in the well will start rising. The time taken by the water to come back to the initial static level before the pumping was started or any other measured level is then noted. In case of this recuperation test, with the help of pumping arrangement, the water is pumped from the well and then there will be some depression. After reaching to certain level, the depression in the well is measured and pump is stopped. When pump will get stopped, definitely there will be incoming flow. There will be a recuperation of the well or rise in water level in the well. This principle is used for determination of discharge from the well or yield from the well under this recuperation test. So this is the sketch for recuperation test. Here you can see this is the well. Initially the water level in the well A is static water level. Initially water level in the well will be static water level and pressure will be atmospheric level. Afterwards pumping will start, water will go on removed and removed. Drawdown will go on increasing and increasing, and then at this level pumping will stop, later as BB, and in that case the drawdown will be H1. A is the initial water level and BB is the final water level when pumping will get stopped. H1 is the drawdown in that case. Right. Afterwards there will be recuperation of the water, augmentation of the water or increase in the water level, and obviously drawdown will get reduced. So CC is the water level at which H2 is the drawdown. Here it is shown in this figure. So now how to find out the yield or discharge from the well with the help of this recuperation test, that we shall discuss in detail. How do we have discussed? A is the static water level in the well before the pumping was started. A is the static water level before pumping was started. BB water level in the well when pumping was stopped. BB water level in the well when pumping was stopped. And H1 is the corresponding depression head when pumping was stopped. CC water level in the well at some noted time T. CC is the water level in the well for any noted time, that it has T when pumping was stopped. H2 will be the corresponding depression head to this CC. H is the depression head in the well at time T1. H is the depression head at any time T1 when pumping was stopped. then dH, decrease in depression head in time dt. Now for any derivation normally we used to discuss a delta small thickness. So here dH is the depression head at any time dt, small thickness or small depression head dH. Thus in time t, after the pumping was stopped, the water level in the well will recuperate by the amount H1 minus H, right? H1 minus H is H1 minus H will give you the water level in the well when pumping it gets recuperated. Again recuperated by dH in time dt. Therefore volume of water entering the well when the head recuperated by dH is, how you will get volume? Area, cross sectional area of the well multiplied by this thickness or small depression head A into dH. So dV will be A into dH, the volume of water entering the well when the head recuperated by dH, where A is the cross sectional area of the well at its bottom. Again, if Q is the rate of recharge into the well at time t under depression head H, then the volume of water entering the well in time dt is dV equals to Q into dt. But as Q is directly proportional to H, Q is equals to K into H. So here this K is nothing but it is the constant, the value which depends upon the type of soil. It is the constant, permanent constant whose value depends upon the type of soil which enters the well. Now dV equals to kH dt. dV will become, substituting the value of Q under this, dV will becomes Q, dV is equals to kH into dt. Here Q is substituted with this kH. Equating the value of dV given by equation number 1 and equation number 3, we get equating the value of equation number 1, that is dV equals to small volume, dV equals to A into dH. So here equating this, kH dt equals to minus A dH. Here minus sign is given. What is the reason? The negative sign is introduced because as time t increases, the depression head decreases. As and when time increases, depression head goes on decreasing, and that's why minus sign is added here. So from equation 4 we have, rearranging this, dt equals to dt keeping left side, ks taking to right side, minus a dH upon kH. And if it is integrated both sides of the above equation between the limits t equals to 0 to t equals to t and h equals to h1 to h equals to h2, if it is integrated both the side left and right, for t equals to 0 to t and h equals to h1 to h2, as a and k are constant, right? So here we'll get updated is k equals to 2.303 divided by t log of h1 upon h2 to the base 10. Since h1, h2 and t are measured in this test, in the above equation here h1, h2 and t, these are measurable, and in recuperation test we can measure the values of h1, h2 and t. The same are known, and by noticing their values in above equation, the value of k can be calculated. So very easily, after substituting this from the recuperation test, the value of k can be calculated, and this k is nothing but it is the specific yield or specific capacity of an open well, which is defined as the volume of water that percolates into the well per unit volume per unit area under unit depression head. So in this way we can find out specific yield or specific capacity from the well by using this recuperation test. The value of k is usually expressed in cubic meter per hour per square meter. Cubic meter per hour per square meter of area under 1 meter depression head. Now wherever this recuperation data is not available, the meaning is that it is not possible to get the values of h1, h2 and t. So the approximate values of this k for different types of soils can be taken as given by Meroit. Meroit is the hydrologist who has worked on this groundwater hydraulics, well hydraulics, and he has found out the values of specific yield or specific capacity in the absence of a recuperation test for different types of soils. For clay soil, it is 0.25 cubic meter per hour per square meter of area under 1 meter depression head. For fine sand, it is 0.50. For coarse sand, it is 1.00. So knowing the value of this K, the rate of yield or discharge Q from the open well under a depression head H may be determined as follows. With the help of this K, so we should know only depression head on this cross-sectional area of the well. K we can take from this Meroit table. So this is all about recuperation test and specific yield or specific capacity from the well with the recuperation test and without a recuperation test using the Meroit table. Thank you. So this is all about well hydraulics and methods of determination of yield from the well. So in the next lecture we shall discuss interference among the wells and tube well and various types of tube wells.